Alright, I'm back. I just realized there was no audio in the first part, so I might end up putting a separate video out, pre-recorded, or taking this and going over voiceover explaining everything I did and how I got there and what it all meant. But right now, I'm just gonna plow forwards, summarize it later on at the end, who knows. So far, we set up the environment, run pre-make, run the pre-build stuff. We took the components and added them in and linked everything all up. So now that we have that done, we can finally run the server, and that will be a lot of fun. This, okay. Alright, so yes, I just fixed the audio. I think I'm not cutting out. Cut, test, test. Alright, good. Sounds good. Have to figure out what these things mean later, but as of right now, we're just gonna continue on working on this. So we copy the files over into the system directory. So let's see what it does now as far as running it goes. And let's see here. Loading. Failed instance. What is that all about? Let's see here. That's just normal stuff, it looks like. Could not find resource spawn manager. So it looks like we need to download the data for the server. Alright, let's go do that. Let's kill that. And let's go take a look. Go to github.com/citizensfx, and here you'll find the you'll find the CFX data right here. And let's download this and see what this can do for us and how we can use this. We'll open this up. Let's go a copy, documents, make a new folder called server data, server tech data, paste it in, hope for the best, on, do it. Alright, there we go. Alright, let's go to the wiki for FiveM to get the server configuration file, what we need to do with that. So I believe it's wiki.fivem.net. Alright, let's see. Maybe not. Oh yeah, there we go. Always slow. Yeah. Alright, let's go to let's see, where is it? Setting up dedicated server, I believe. Build artifact, yeah, here we go. So let me just adjust my microphone setting real quick. Now it's getting some noise in there. Where is it? Gate. Alright, I'm back. Volume, audio fix, good. Shouldn't be hearing all that extra crap from my mic now. So, alright. So we're in here. We are going to go down to the server configuration file. Let's just copy this crap, whatever this stuff means. And let's go over to server directory. Make a new folder and call it server or new file. And call it server.cfg, and we'll do that there. And let's open that with what text editor do we want to use today? Notepad should do fine. Paste that in there, and I'm gonna make sure to save this as server.cfg, but I want to save this. One there. Open as save as UTF-8 because I think that will do fine. Hello world, hey world, funny. My new FX server, let's call this YouTube test or something like that, like YouTube testing. Master race, no, master. Argon password, let's do yay. Script looks loud, good. SP master, minimum auth. Alright, so. Okay. Alright, so. Let's see, you got ace principles down here. You have. Don't allow quit. Funny, okay. Alright, so add principal identifier, Steam. Okay, whatever, I really don't care, but okay, now we have hide player endpoints to external log. Alright, well, whatever, this should be good. I hope. I think so, well, yeah, it will be. So, save that, and let's go run this, and see what will happen. Hit run. And we have a cannot find resource session manager, and you might be screaming at me being like, hey, use CMD file, use CMD file. I know, it will work doing that. Thing is, we want to be able to go in here and stop the program when we're doing our development and see how variables are changing and stuff to help speed things up instead of guessing and add a bunch of console outputs and crap, because that will waste a lot more time. So all we have to do is go down to duplicity main, and duplicity main is the main executable folder. You see here it is under here, well, whatever. Well, we want to open up properties, right click, go down to properties, just hit alt enter, and then we want to go to debugging, and first we'll switch this to all configurations. And then we want to go to debugging, and we want to specify the working directory. Normally you would cd into the directory and then be like, oh, go over here and run this, and it'll automatically go and just run it. But we want to run this in, let's see, we want to run this in the, shoot, where is, browse, code, documents, server data, run in here, select the folder, good. And then we want to run target path, which would, you wouldn't know what that means. That's actually, if you look at the bottom down here, it's actually the SystemX server exe folder. So what are we missing? Well, we are missing the, let's see, isn't it set citizen underscore dir, and then it'll be plus exec server.cfg. So with that, we need to hit edit, let's insert here, space over, let's go macros, and we are looking for a mark name or variable called target directory. Let's see, should be in here somewhere. Target path? Don't know. No. Target, here we go, target directory right here. Alright, so we want to throw in target directory like that. And we want to run that, and then you want to put another slash at the end, because I believe there's an issue with how it interprets all this stuff. So add extra slash at the end. It says there's 2 slashes, but there's actually only one when it gets executed, I believe. For some reason it doesn't send them all in. So run that, hit apply. I think that's correct. It might throw an error though, so let's find out. Let's run it. Let's see. Yeah, could not find resources, whatever. Let me go check my version on my local system, see what I have mine set to. Ah, I saw. Okay, so what we have to do is we need to actually point to the citizens directory, not the target directory. So it's something like that, /citizen. Alright, that should do job. Now, when you go into edit and you look at this, if you don't have this here, you're like, oh, we'll be fine. You're not actually fine, because Windows has a thing where it represents directories. If it's like the top of the directories, this variable will be the top. It'll just cut the slash off, and because that variable is a directory, it'll cut the slash off, and it'll just be debug citizen as one thing. It's like a file or directory itself, when it's actually debug /citizen. So we need to add that extra slash in there to have it work right. Then we hit OK. Then we hit run, and this should be what makes it work. No, it's not. So that's interesting. Alright, let me just copy and paste mine, see what the difference is. Alright, we have backslash like that. Alright, well, I must have not had double backslash in there. My fault. Like always, things mess up when you don't want them to. Alright, good. Let's run it. Should work, shouldn't have those double resource errors. Yep, found a resource, things are working, and we have these weird artifacts popping out. So that's how you run it. It's running now. You can't connect to it. You cannot, because my firewall won't let you, and I really don't feel like dealing with that. So as for right now, just trust me, it's working. Don't have those errors. So let's see. Okay, so right here we have these weird artifacts being printed out. Now, we know that doesn't happen on standard, and we added a component. So the issue probably is the component. So let's just see how we're going to figure this out. So we have no clue what we're looking at. We're new, let's say. And let's see, we're going to components, FS Web, that's what we added. Let's just go through the source, component, let's see what that's all about. Stuff, interesting, don't know what this means, whatever. Okay, whatever, this doesn't look useful to us. Oh, what's that? Wonder if that actually works. I added that. Coordinates. Let's see. Trace. Ooh. That looks interesting. Wonder what that's all about. That's probably the issue. Let's continue going through. Another trace, huh? Could that be the issue? Maybe. I have to register. It looks to be in a native, so I doubt it, since that native probably not being called for everything, so it's appearing in everything. Let's go to HTTP handle. No. Doesn't look to be in there. Include folder, possibly? Coordinates, maybe? Let's see. Nothing useful in there. Utilities? Authorization stuff, username parsing, password checking, don't see it. Info data. No, I don't see any purple traced words anywhere. Local. Nothing. Player info. Nothing. Doesn't look like it now. Server data. Nothing. Okay, so where do we see none includes? Solomon source. So we saw it in coordinates. So let's see what we have. We have some register native handle, and that, and then this funky thing right here, and whatever that means, and then we go to on server connect. Okay, auto static, whatever, on trigger event connect. That, payload event name, that looks like, wait, new line, sm/n event name, payload name. That might be it. Let's have a trace to string. Well, I believe this is it. Because, let's see, it's on trigger event. And it'll also be just taking in the event name, the payload, and event source, and event cancel. So it's probably spitting out gibberish because it is taking the payload and turning it into a std string. No, a C string, I believe that is. I believe it's turning it into a C string. Not sure. No, std string, which, whatever, goes to string, out to console. But as if you know enough about how the FiveM development works, you will know that the message parsing with the events uses message back, and you have to pass things as arrays and lists, especially in C#. Everything comes across tables. Wonder why? Reason is it's mesh back. Mesh back packs everything down to optimize bits and bytes, and sends it over the line that has to be decompressed on the other side so it can be interpreted and used. So with that, that's probably where our gibberish is coming from. So let's comment it out, double slashes, and let's just run it again and see what it gives us. Alright, I don't see any gibberish. Is that gibberish? It looks like some gibberish to me. I can't really... I don't think I see any. I think I saw some still. Oh, do you know why? I just remembered we have to build it again. It doesn't automatically build when you hit run. Let's go build. We could build solution, build FS Web. I just hit Control-Shift-B. It will run the build down there. See it? Coordinates. Crap. let's see what it outputs for us. Oh, Z partial PDB, just compile the things that changed, coordinate folder, and let's just hit F5 to start debugging. And let's see if that gibberish went away. Yeah, blah 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 blah, found, CFX, yep, our gibberish is not here anymore. And that's the issue. So we can comment, we can just leave that be just for now. Just let it go. So we got one thing solved. So let's see, what else could we work on? Well, let's see. HTTP handles, let's see. But you know what? Before we get any more work, let's understand how this actually works. Alright, so where to start with all this? It's very complicated. Let's go to the main binary, just walk through it. So we have the client comment, see, client stuff. Include server. So here we see namespace fx server class, and then we have this has a accessible start method which gets run somewhere by something outside of this class. We have our main, which has our fx, makes a instance of the fx server object, makes an fx server object, and then calls the start. So let's go to server. Alright, public void run, and it is a pure virtual function, just like an interface in C# in a way. And then we have a macro right here, or define, that will, macro I believe, I don't know, but it takes that, whatever declared instance type is, I do not know, but we can right click, go to, let's peek at the definition, and see what that's all about. Okay, so we define any name, template. Alright, so as you see before, the registry at H located in the client shared registry, although this is the server component, it still uses stuff in that client directory for some reason. So I don't know why it's not in a shared, but like I said earlier, in here, but yeah. Okay, so we have this, we have some instinct stuff, so it looks like a template to make some instance of a name, then have some null pointer thing, I don't know, but whatever. SS stream with some boost stuff. Oh, here we go, component loader. This is the thing that actually loads the components in, and it will basically load components, and we'll go through the JSON file, components.json, and load in all those DLLs. And I'll show you and explain to you how that does it later. But right now we're just getting an instance of it, and then we're going to run the initialize down here, which is, let's see what that does. Initialize while true. Okay, return while true, set user data, shut down. Alright, just a bunch of virtual functions. So, whatever, we'll get to this later. Alright, so, let's see, oh man. Yeah, good. Alright, so, here is an FWRef container. This is one of the things I consider to be part of the Citizens FX framework, is these FW classes. They are generated, I believe, from IDL, and these are the main things that they use for containerization of objects and so forth. Let's see here, class FWRef, and yada yada. They take a lot of ideas from other programming languages such as JavaScript. They have callbacks, they have incremental ones, just a bunch of futuristic stuff that that the person created to do some of the stuff in C++ and abstract some of the complex stuff away so it's easy and more efficient to write the code. Now here we're going to do a for loop on all the components. So it's like you have your component loader, which is a component, and then you have get instance. Get instance is going to grab the versions that load in the registry, and then we'll run this address. We'll run this because now they're doing the get instance because you're going to have it load into the memory space, and with that you need to find the instance that is actually initiated and is in the heap. So you'll have like your initialized version or version in the code. Then you have your version that's off, actually have stuff that's actually being used, and you want to reference the same version everywhere in the code to make things work. And this is how they're doing it. Just doing a component loader, get instance, and get instance, I believe it's a static method, so even though it's actually in the code, it's always going to be pointing to the same method, and that's in the heap all the time, no matter which thing calls it from what component or whatever time is, however long the program's running, it's always going to return that same memory address, which will be pointing to the component. And then we're going to have a for component, which is running something, which is going to be like, we'll run a function on everything, and here you'll see it's a lambda, or a what they call in JavaScript callbacks, and basically it's going to use references, so whatever data gets changed inside of here is going to be reflected outside of this lambda function here. And then we're going to have another container which will be component data, and then we're going to be basically getting all the instances and initializing them. So this is a key component to understand. Initialize there is, I believe, is the same initialize as you will see here. Right here you have initialize, you have this inheriting from a component. So yeah, this inherits from component, and so this has component, this has initialize, we have this here, and that's FW countable, which is one of those FW containers, yeah. Mumbling, don't know why. So with that, we have initialize, do game load, shut down, initialize here, and this is where they all actually get implemented down here. This is the actual code that runs. That's just a interface up there defined that says it's available in here, and this is the actual stuff. I'll be right back. Alright, I'm back. Sorry, life calls. Alright, let's see if I just messed up now. Let's see. It's stream. Good, still, broadcasting out. Alright, so, let's see if it's still right. Alright, still looking good, alright. So, with this, we have initialize runs that, does game load, where was I? Let's see. Instance initialized, yeah, so it's gonna basically go through each thing and run the initialize method. In here, I was seeing if cout actually did anything. I don't think it does actually do anything. Just do a like a backslash n backslash n. Let me just throw the front, see if I can actually see it in the screen next time. And then that's that, and then we're gonna do, let's see. And then it's gonna basically say, if you can't find the reference to it, just throw an error, yada yada. Replace some strings, and we're gonna say create component instance. This is where it actually creates the server and stuff. Yeah. Okay, so that's server.cfg, and then when it runs the server.cfg, it basically, let's see here, main server. Where's this send us to? What did I just do? I just hit some buttons and messed everything up. Oh man, what the hell happened? There we go. Let's get back. Alright. I want it. Control F12, server main. Gonna basically do that. Go start, run, start, yada. Oh, we just did that again. Instance I get. Alright, so it's going to do. It's getting an instance of server main and getting it and running it and passing in component instance, which is equal to a server component, which is doing that. Alright, so it's gonna run component instance, there's that, and I'll show you what that actually is. That's basically an implementation, because server actually is a interface like you've seen before, just defines what should be in it. But we'll go to citizen server main, and it's just a interface. Actually, no, this isn't an interface, but yeah, this is just me command line parsing out, so I messed up the entire time. Oops. So it's the main command line parsing, has SE stuff in it, and let's see, ACL stuff. Option parsing is where options get parsed. It's like right? I believe so, or maybe that's in the console, but yeah, options get parsed to your server instance, yeah. And then it all ends up, let's see there. Okay, so one of the things it actually initializes is going to be this right here, citizen server instance. This is where all the magic happens. Or no, not here. Implementation. This is where all the magic happens. Okay, see all these files, your info/info, your client registry, your HTTP handle for /client, your /files, info, HTTP script functions, password stuff, player script function, stream stuff, and this is where all that occurs at. So yeah, you got all this stuff. So let's go. Let's see. What do we want to do? Alright, let's go and explore what we have in FSX Web. Alright, so JSON stuff, isn't needed, I don't think. No, it's not needed. So I can remove the JSON includes. That's not needed. We're not using JSON in this folder. What's this complaining about? Definition is auth. I don't think we can comment that out for now. I don't think it'll cause any issues. Let's see, does match. Alright, that's for regex stuff, to abstract that stuff away. Alright, so down here we have our regex. This is how all our stuff is parsed. I can optimize this. I need to think about how I'm gonna do that, and I have multiple ideas how I'm gonna do it, but I still need to haven't figured out which way I'm gonna go with. So yeah, up here we see I am doing an instance dot get component console context. Alright, so you see init function right here. It's running that, going out here, and you might be like, oh, info data, what's this mean? Something make shared, that's a thing, instance gets component, so console context. So with an instance, it's passed in from here, which gets an instance of a server base, which is the implementation, I believe. I believe it's implementation. Don't know, don't quote me on it. So we have, see up here, we have the square brackets up here. We have square brackets with the parenthesis signs. We have this down here. We saw this earlier, it was a lambda. This time we're not, it's gonna automatically detect what should be, if things should be copied by value or copied by reference. So with that, we have it stacking it, but we're like, okay, so you run it and you're running a lambda. So how's that lambda being executed? How's this init function being executed? Well, it's being executed in its component.cpp. We have init function base run all. So let's go explore init function base. Haven't done before. Let's see. Register run all. Init function. Alright, so we have init function, and ooh, that looks familiar, doesn't it? That looks like what we have in here, init function. Let's see if it points to the same place. Ah, it does. So with that, we know that that it's running that. So up here we have init function base, and we have that next. So we have more stuff that is somewhere used elsewhere. Alright, let's see. The function base, it's doing that, it's getting function, it's registering it with some sort of register, I guess. So it's just running all these functions. That's interesting. Let's see if we can see where. Let's see if we can find out where the run is at, because that would be cool too, but probably not. So whatever. That's interesting. It's in utils that H file for the CitizensFX framework. So it's gonna run that from the component file. Because remember earlier it ran initialization all of them. That'll be part of it. I'll be running that initialization, make it in here, and then it goes in the lambda and runs line by line here. There we go. Oh, found a match. Project stream. Oh, virtual function, whatever. Alright, so we have a console index and instance. So it'll be FX server instance base on server create.connect. So how does that mean? That makes no sense. Like, what the hell? Well, we saw instance base. That's some sort of thing that has an instance of something that is passed around and contains data that we use to get instances of other things. Kind of like the thing that is the thing that holds the memory, all the memory addresses for all the components that are loaded that are actually being used. So let's take a look at this. It's the base. Yeah, we saw this earlier. So FFW event. Interesting. What's an FFW event? Let's see. FFW event. Connect proxy function. Stood function. That's used to actually do things. You actually attach something to a stood function and it runs stuff, and it looks to be used as a template, I think. And then we have callback. Look, callback. Here's that callback we saw earlier in the lambdas. So function, and then it takes, let's see, strut callback. We have a function, we call back next. In order to run them in, we have the actual callback. Then we have, this is the constructor for the callback, I believe. Yeah, callback, func takes a function, which would be a tfunc, and then it will default as a function of function. That'll be the default constructor right here, which, yeah, makes sense, because instead of doing like, instead of doing down here, instead of saying function, let's see, function equals, or instead of doing function, this is how you instantiate in C++, you do parentheses or brackets instead of doing equals new like you would in C#. But here you do like parentheses. Instead of doing that, come a function down here, or even assigning it function like that. Actually, yeah, just be this. Actually, overriding. It's overriding this, not the instantiation. Making a video, and then it's actually, this is will be overriding. Be overriding the assignment operator, and then instead of writing this in here, you just put it up there. You can chain them and make life easier on yourself doing that. You'll see I've used it in my own code. So we have callback, and then we have some public stuff, FW event, some other stuff. So kind of callback, I guess we can say. So it's like, oh, on the server create, and then so it's all something to do with some sort of like executing stuff, I guess we can say. It's all trying to execute stuff. Now here it's a base on server create, and an FW event. We saw that before, haven't we? Just take some sort of, what does it take? What does it take again? I can't remember exactly. I meant to hit peak. Peaking. Why are you not peaking? Here we go. FW event. What's it take? A boolean. Huh. Weird. Alright, whatever. Alright, but it takes instant base, does stuff like that. So yeah, and then it's like connect, and this gets fired when the server implementation actually starts. I don't know where it gets started at. Maybe we'll come across it later, I don't know, but I don't think I'll be able to quickly find that because I don't actually know where that gets run from. But yeah, runs that and then passes an instance of it. So basically, this is starting out in like nowhere, and then it gets attached to the instance that gets passed from the server. It runs a connect method, and then it basically runs all the stuff in here. So it's like registering, and then it'll be like, ooh, and then it actually calls the connect. So connects like, I'm gonna add myself to the event handler for the server implementation. So the server implementation actually runs, it's actually gonna run whatever it has in here in this lambda, and an argument of that, I guess you can say, event handler would be passing in an instance that would actually be able to point it to the rest of the other data we can use. So we can get player data, server data, resource data, or no, just like components. So we get other components, sorry. So down here we have info data, which basically generates something I wrote, or actually it's something that kind of like what who are they? They are the elements in the FiveM. They actually wrote this. I actually took it and then modified it slightly. I think I still gave them attribution at the top. No, FiveM scripts. Okay, well, whatever. Modified it, cleaned it up, add stuff I wanted to add in here. The make share is basically a variable to make sure it doesn't leak memory, but also make sure that other things will hold on to it, and then when everyone detaches from the object, won't leak it. Now, because it's static, it shouldn't happen, but just out of good practice, I want to make it shared. Then right here, I'm just saying creating the FS server, and then we're just saying the name, second argument, whatever that does, don't know. Alright, and then we have the regexes. So these are used to parse the paths that you enter in and will help check if you are at a valid path or not. I was doing a bunch of nested if statements. That was becoming a nightmare, so I sat down, basically worked on using std regex and finding out a way to use regex to clean up my implementation of this. So this is what I have. A bunch of this stuff. I'll probably in another video or look it up on your own how to learn regex. There's a website called, you can search on your favorite search engine, just search regex 101. There should be like a regex101.com or something. It shows, it's a great way to learn regex. That's what I found. You input your data, you select what kind of regex you want, implementation, and then you just start pounding on and seeing how things are described on the right side and working on it. And then when you sleep, wake up, try it again, you'll understand a little bit more, and over time you'll eventually get how regex works. That's, although it's not a conversation to have right now. Alright, so smatch is where the regex values get stored so I can evaluate and use them later. So down here we have instance, git component, HTTP server manager. Now this is already, I believe, instanced. I don't know where it's instanced, but somewhere it's instanced and set up to listen on the port you define in your service CFG. So if you can find where a service CFG file is read from and those variables are set from, follow that along, you'll end up finding out where this gets registered. Now adding an endpoint, fs data. So this will catch anything that's like /fs data / whatever, not just /fs data. So it's kind of like dynamic router, but not really. You have to implement dynamic stuff yourself. And then it would, I'm doing a pass by whatever covered by value here for everything outside of it, and then then you get inside of this lambda function, you get a request and a response. Request is what's coming in and you can use. Response is what you set and then you send out. Alright, so okay. So the first thing I do is check if they're authenticated, and with this I basically found out how to do authentication. I just implement HTTP basic authentication with some random crap in here, which I should really switch out later, but let's just add a comment. Slash. Alright, it's for later, good. So here we have we use auto, which is kind of like var. It automatically deduces the variable type based on what it's getting equal to on the other side. Actually, yeah, it's almost, I think, like var in C#. Someplace you can't use it, I believe. Don't know off the top of my head, but yep. Okay, so it's being passed there, it's being passed off to a get password, get username. Now, this is interesting because we're using the Windows libraries. It thinks it's referencing Windows, but up here I had to Up here I put the it's called for declaration, I believe. Predefined them, I don't know, but put it right here so it knows, oh, it's not Windows, it's actually this component. Visual Studio is not smart enough to figure it out for some reason, but whatever. So right here I'm checking if, so let's just see what this does. Oh, get password. This will basically, okay, variable manager, getting component, we're going to get the console component, a context, and we're going to get the variable manager, which holds all the variables. Then we're going to go find the entry that has the variable for fx password, and they will be setting that as a convar variable in your server CFG folder. And if it comes back as a null put, if it's not a null putter, which is it's not equal to anything at all, not instance at all, that means that if it's not that, it has some sort of value, then let's use that value and not return empty. Alright, so I could return null putter probably. Probably just propagate it backwards. Just throw a to do in there for backwards, or let's call it bubble up. Bubble up the null putter. Alright, we can look into that later, see if we can bubble that up. Alright, probably clean some of this extra code up. Where are we going? Let's see here. Let's go back actually. Back. Oh yeah, get password. I'm gonna get the username, which is the same thing, but it would actually fetch the username and Windows. This is not smart app. Oh man. Alright, let's see if I can find it real quick. Get username. Okay, yeah, same thing, but for username. Nothing found, then we're gonna do that. Shoot, I need to do that. Uh-oh, what's happening? There we go. Oh, well, to do, whatever. To do, in space that. Oh man, I want to cough so badly. Alright, good. Alright, so add to up here, bubble up no pointer, no putter. And then we're gonna go to, let's see, back up here. Oh yeah, here. Okay, so the way I learned to do the HTTP basic is I searched it, I found the RFC, but also HTTP basic. One thing I did come across, HTTP basic authentication. Let's look up Mozilla. Mozilla should be good enough. Right. Authentication. I think this is it. I don't see this is the one that, yeah, here you go. So I use this diagram right here. I use this diagram right here to actually implement the basic stuff, and with this it helped. I was able to write it kind of weird, go through it. Hopefully you understand it. Hopefully maybe let's see, back is off, so it's gonna get that if it's 0, and so if both of these are 0, it's gonna return true, saying authorized. So basically, if you don't define them, it will. Well, yeah, because it's gonna return a string. It could be that. I could just say if they're not if they're not instance, then do that. So we can do that later. Alright, so it'll take that request that I got earlier, and then it will, let's see, get the header authorization equals std string. Then it'll check if it's a, let's see, this will check if, okay, this will check if it has authorization or not. Then if it does have authorization, it'll send status code 401, needing authentication needed. Then it'll send authentication stuff and do all that fun stuff. Turn false. Whoa, man, my neck. Then we're gonna do a authorization.length greater than 0. I believe this is used for what, the first authentication. Check credential. Alright, so this will be checking if the length is greater than 0. The reason why I don't do that up here is because it doesn't actually have a value at all. So if I check the length, it's going to give me a runtime error basically saying, oh, can't get length because it doesn't exist. Can't get length, something doesn't exist, so it's basically a no pointer object. No pointer exception, I think. Or maybe get header returns, I'll put her. I don't know. Let's see if we can check. It does return a default value of. Just returns a std string. Turns a instance thing of a std string as default value. Okay, so. Alright. That's why I checked it. So basically, if it's that, then I know it doesn't exist, so that's why. So it doesn't exist. And first time to come in here, just I ask them to request, give them the ROM data. There we go. So here they've been here. They already sent us the credentials with authorization message. Come down here. This is the stuff to check the password. I got this with help from the people from C++ Slack channel. Compare it, send it 4 to 3 if it's sent password is incorrect. Then otherwise, while that fails, it's gonna send status code 500 error has occurred. Alright, let's see, free the buffer so we don't allow exceptions. Maybe we could do a, I don't know, but yeah, whatever. Alright, let's see here. So that's that pretty much. Pretty crazy overview of that. So that I showed you to do that. I showed you how that works, authorization. Now we're just checking if it's GET requests. Don't want weird stuff going on where they just send post data and just have all crap security thing mainly. Now here's it does match, gonna do GET path, then we have a std regex which we have defined up here as fs data players. Right, so we could actually fix that by adding a end symbol down here, but I'll have to look into that later. Let's see, slash to do. Alright, there we go. Tighten things down, doing that, looking at that later. We have, let's see, we have this, then we have L, which probably should rename that, but whatever. Alright, okay, then we have kick, and then with that, we'll basically check what their action is, cause player enet is equal to, what's that equal to? Bam, bam, bam. Okay. So let's see. So we have the right here. We have a capture group between two parentheses. It'll be backslash a digit, any digit that is a length of 1 digit long to 3 digit long number. and then it'll be, and I'll have double backslash to escape because of the string. And then we have slash action slash, we have a possible choice of 3 different actions we accept in this regex for it to be valid: kick, ban, or message. And let's, and the 3 messages are as a pipe character, and then because they're in parentheses, they come across another action, another capture group, which is I think that's capture group, yeah, capture group number 2, which will be kick, or ban. Now this should be message. There we go. Alright. Now I was thinking about doing that case, but you in C++, because how strings work, you can't really case strings. You have to map them to an enum value, and as of right now, the little bit of data I'm working with, I don't find it necessary to do that yet. I might do it in the future when I start making the regex strings more abstract and more dynamically generated. Might do it, but as of right now, not yet. Okay, I have to do the app players net. Then we have, let's see, what's this? Does match server, same thing. And then we have info dump stuff. Info dump, which is dumping data. Since that's go 200, I should, for consistency's sake, throw it in there. Alright, and then we have, let's see, does match log regex. Okay, so this is where we have the regex log working out. Okay, so we have, alright, so we have log file open, makes this a relative path. This is one of those utility functions that they have, which basically calculates out where the citizens directory is relative to everything else. And I just say a citizensfx.log c string, because this takes a constant start pointer, constant character pointer, car pointer, yeah, 4-byte pointer, whatever. And then we have, or 1-byte pointer, I don't know, whatever. Alright, so we have a line, let's see, line, whatever. Okay, then we do a, let's see. So while it's open, we just go through all the find, add to the log, and then we do that, set header type plain text. Then we end it, and pass back. Oh yeah, sorry. Alright, then we have does match log action. So I have this. What if method is this in if you want to check? Okay, it's just a root if method. Alright, so I want to probably space that out better. Alright, so we have the log action, that's like the other ones, and let's see what actions we can do with this. Let's see, 12, all of Tosins, oh come on, Visual Studio, there we go. You can clear. Let's also do a rotate. That was suggested from our prior group to add rotate. And let's just put rotate above log just because it makes more sense. Yeah, even though I define it backwards, whatever, don't care. Let's see if, does match. Let's go get the request. And we want to take a pointer to the C path. So it's a method, and then we have to take matches, get stored in L, and then we have to take the regex, which would be log action. Oh wait a minute, we could just do, what am I doing? I don't need all that crap because we have it log action like that. We could just say, oh sorry, if, let's see, L1 equals, actually L1 equals rotate we could then, oh wait, equals rotate, then we just say bam bam to do implement log rotation. Alright, we clear it, basically open it, and then we truncate it. Now that works because when you open it, you have a pointer that goes through each character and line. Basically goes through them all. Truncate just cuts everything off after the pointer we're pointing the file and saves it out. And that's what it's doing right there. It's doing that, truncating it early, and then it's gonna close it and be like, oh, no data there. Easiest way I found to do it, as I looked online, Stack Overflow. That 1500 is when in the cycle it loads this component compared to everything else, I believe. Might be wrong, but I think that's what that 1500 stands for. So that's an overview of the main HP handle and how that works. Let's just go take a look at, let's see, let's go with player data. That's interesting enough. Okay, so player data, we pass an instance because we're going to be using some of the console stuff to get variables out and player registry stuff from the main server implementation. Alright, so we have, let's see, we have a pointer instance base, JSON data. All this is in a player data strut actually in a header file. Here's our main instantiation, and we see right here we have that colon, and we have some variable data. I do that to make things a little bit easier. Now I can actually, I believe this will be valid too. Wait. No, I don't do that because it actually works. Let me see. Instance underscore base underscore. I don't think it takes it. Oh, it does. Instance. Oh, it does. Oh, interesting. Okay, well then that makes sense. Because it would, because it'll be a available thing. Okay. Now let's see if it builds. Made a build. Let's see. Hopefully it builds. Core. Crap. Shoot. Hopefully I didn't mess them up. Oh man. Oh man, better not be compiling too much. Shit. Sorry for my language. Alright, so it's gonna instantiate player data at the top there. Up here it's gonna make an instance of player data. It's gonna do that, it's gonna update it the first thing it does when you make it. Basically it's gonna make a JSON with player array. Then we're gonna go do the client registry, which I should point up here is an instance where we get the component of client registry, which is defined, I believe, in the server implementation. I think so. I don't know, but that's defined server implementation. Then we have that. We have players JSON. Then we do a client registry. Then we do a for loop, and we use the right here reference because we want everything inside to point and modify the addresses of everything outside. If we do the equals, it does not work. I don't think it does. No, I don't think it will. No, I don't think so. Alright, so we have client. So this lambda function will take in, it'll pass in a client because we have right here, we have the constant stood shared pointer of an FX client, the reference to that. We have the callback, so that's the what I'm putting in there. Alright, so we make a JSON client object that we're going to add things to, and then we have our client get name, which will be the client we're currently on, that we name. Then we have client name equals that. Now, the reason I do it this way is because I don't know, it should have been optimized out. Let's just leave that for later. So we're gonna have client get data coordinates. Oh, this is a special thing I did. So basically, you have get data coordinates has value. JSON coordinates equals object. This is stood anycast. This is new in C++ 17 as it. I think C++ 17 or 14. One of them. It's I think 17. Where it's stood any. Where basically you can put any variable in there, and then you can then specify it through a template of like what strut is. I did what strut the value is equal to, and it'll translate the value both ways when you set it and get it. And right here I'm doing the client get data, and basically it takes a string and returns stood any, and I'm gonna do casting it, which will be an any cast, which is just a I believe reinterpret cast underneath the hood, because I have it at runtime I believe. And then we just set x, y, and z on that, and we have coordinates down here, and just say coordinates equals that. Now this is all written this way, so it comes out in the JSON. So the JSON is properly formatted. I thought I could optimize this and save some code, but it didn't work. So that's what I got. Then we have last seen identifiers, net ID, GUI, net base, TCP endpoint, and players. TCP endpoint is interesting because I believe with TCP endpoint I can get like bandwidth stats and stuff. I think it is. Is it this one or here? I can't remember which one it was. One of these I can get like network stats off of the player data. Okay, well it doesn't want to work right now. Telsense doesn't want to work, so that's fine. Just kill that build for now. Alright, is it just dot or is it wait, here we go. Applicant question, no, so many things to try out. No, okay, is it get peer? I can't remember which one has the as a net base. I can't remember. So many different ones to choose from. Well, one of these has an option to be able to get the data from the client, like ping stuff, ping bandwidth use of that client relative to the server, and like what server stuff they're not doing, like how much bandwidth they're using up on the server and things like that. So that'll be fun to play with. Probably peer actually. I'm supposed to comment it out, but I don't know why it's not giving it to me. Oh wait, just here we go. Yeah, so we have data dispatch commands, dispatch list, host. That's broken for some reason, it doesn't work. Incoming session IDs, MTUs, go data, packet loss, packet loss. Sorry, so we have packet, like threshold stuff, timeout, limit, max, window size, all this stuff you can set per client if you wanted to, so you could have so much fun with that. Round trip stuff, unreliable commands, so you can get some really low level client work done using that. We got some private stuff. What's this? What is it? What's this used for? I don't know what this is used for at all. Oh, this is used in. Actually, I don't know what I use this for. What do I use this for? Let's see. Find all references. Let's see. Get player. Okay, well, I don't know why I have this. I think I was gonna use this for nesting player infos in server info. So yeah, but that's a project for a future us and have fun with later. So Now we just look like info data, and this is similar. We need to restore the oh wait, variables are here. Should be showing up. Weird. Let's do. So right now we have a bug with the output of the FS data slash server. I think server.json is server. I don't know. It's just slash server, and it doesn't output these variables for some reason. I believe. So let's just add a to-do to fix these variables. Oh shoot. Oh, come on with it now. DB low variables var whatever. Screw it. Alright. BB001 good. And then we have, let's see, info.json version 0. That's a bunch of crap, whatever. Resman for our resources. Here we get the resources I just loaded up. Now I thought I had. Oh, where is it? I thought I was doing like server data. Like, why isn't it's server data that should be in? I don't know, but yeah, but we're gonna have to clean this up later. Like, this is really like half-assed put together, unfortunately. I don't know why I did it that way. I don't know. Half asleep, half awake. Working all the time, doing this in my free time, so that's why I see resource data. I don't know. Cleans up later. Should make it look real nice, real pretty. Will work great. This FSU2 went through this. Let's see. Oh, here's something. Let's see. So here are all the instances of a state you get. You get set, started, stop, stopping, and I use this to convert the JSON data for the resources into the state right here. So you have state equals fs state to string, and then basically it gets the resource name, and then it'll basically put the, what is it, where the hell is it? Up here, you take the resource in here, and then just takes the resource, gets the state, and just outputs the string or whatever. Now I could probably be better for me to actually get the state of it in here, pass in as a constant value, copied value into the state to string, then return a value back. That'll probably be a more efficient way to go, but I'm not 100% certain because right now I'm just passing a reference to the resource, taking a reference. So yeah, it's hard to tell. No, this would be probably a more efficient way. Alright, so last thing I'd go over is chords. Now the coordinates is just a float x, y, and z. Now this may look really crazy, but we've seen this already, pointed out multiple times already, but the colon after constructor here, this constructor equals the same name as that, fish strut, and it's heard from student any like this. Actually, this isn't even used, so yeah, I don't think it's used. Oh no, it is used. Yeah, I do use this. I think I do use this actually. I think I use it, or do I? Let's see. I can't remember right now. Yeah, I do use it. Yep. So I do use it. So you have X, Y, and Z. Basically, I instant coordinates, and you have X, Y, and Z. You throw in here. Then over here, you see it all instantiates these like that. You have values down here. Automatically done by C++. No magic, no manual extra typing needed. Less code, less bugs. That's good. Really simple. All we can ask for right now. Alright, that's the include files. Let's go to, I think the final file is coordinates. And let's see how this goes. Alright, so we have, oh god. We have get coordinates, which is basically a register native handler, which will automatically run that hash, the Jode hash, whatever, which will generate the hash for the coordinates. So basically outputs that hash name for get coords, then you call that in your server script, call get coords, and it'll come here, pass in context, like pull out the parameters you pass in, there's parameter like 0 through whatever, then push result back onto the stack, which is passed back into the scripting environment, and then you receive it as the return value back, I believe. Alright, then we have the on-server connect. If you remember right, this gets run when the server implementation gets run. And then we have to see, we get the current resource manager as L, which we should rename. Then we have, let's see. It's hard. Okay, then we have, let's see, we're getting a resource event manager component. Alright, we're getting somewhere. Let's see, j.trigger.connect. Huh, that looks familiar, connect. Oh, on server connect. So, let's see, on trigger connect. So we're triggering on an event that happened. So an event gets fired on the server because it's getting an instance of it from above with L and up here. That means that it will be getting an instance of it. So there'll be when it connects. So when an event gets fired on the server, we're gonna do something. We need payload, then source, then canceled. Interesting. So with my work, I still need to figure out if messagepack.c messagepack for C will decompile or will demux or make sense of the event payload that's good passed into the event. So you can use that too. Used to intercept the event before it actually hits the runtime environment, I believe. I believe that's valid, or you can just use it to ship a component with a client file and not ship a server file as the event has already been implemented into the server. So, see down here we have check argument. Basically, check argument is a good thing to use because the elements use it. No, not just because the elements use it, but because it sets and checks to make sure argument is actually not null, and it will return the argument at the end. So it's not like, oh, check argument, then you have to go get the argument later. It does the same in both of it. So it returns argument, it checks and returns the same function, which is very useful for them to do. So, alright, so we check to make sure all those are floats. So we set them as X, Y, and Z. We do the, oh wait, let me go back, oh, okay, sorry, alright, so we have player net ID as the fourth argument in the function. Then we have the client registry, we have client by net ID, we can also do client by like endpoint, we can do client by a few other things. Let's just see. Get client by GUI, net ID, peer, TCP endpoint, and endpoint, GUI, net ID, peer, TCP endpoint. So you can do all those to see if the to get a client. So you can expose those other ones as an HTTP endpoint, and then pass them back into a function. Be like, oh, we want to get this person based on this, whatever, and then and just get them that way. I don't know. Depends how you feel like doing it. Depends how you clean your code and abstraction and all that. So we're going to get it based on net ID. Then we're going to set the data as coordinates. Then we're going to say, because set data takes a stood any, takes a stood any right here, as data. It's going to set it in there. We have to run make any of the strut we defined other, and then we have cores XYZ, all like that, real clean, really nice. So we see we have this 1500 loading area, which I believe all the components use. I don't know because I haven't checked them all, but that looks to be all of this. Let me quickly, before we close out, recap some of the stuff that you might have missed earlier as far as the layout of the project. So Duplicity main is the main project that actually has the server. This folder falls under the code server launcher source code. So let's see if we can go to the directory and take a look at what folder is, get some context about all this. Alright, code. Wait, oh wait. Right here is server directory launcher. This is a Duplicity main. This is the one that generates the Citizens FX or FX server exe. Alright, we have our shared library, which contains like client stuff, which has like not so much client stuff, but now shared stuff, which don't know why it's in the client folder, and here's in client shared. Then we have more shared stuff in here, which is under, what is under? Under actually documents, code shared. FiveM code shared, this is under, okay, so for some reason they don't merge that together, so whatever. Then we have what, launcher. Okay, this is the main game, that's the FiveM.exe launcher. Then we have a shared libc. This is a Windows specific component or file. City core, which is, let's see what this is. This is like the core RT, I believe. Yeah, city core. It's under what client? FiveM component load. Wait, FiveM client. Yeah, FiveM client city core. So this is the, let's see real quick, under properties, general. This is the core RT library. This contains, let's see what this contains. This contains the main models that are used in the game. You have FXI base, you have core stuff, you have, let's see, FX base. This is one that's generated using this FXO base gets generated using that Python IDL stuff that you had to set up earlier and run with pre-build. This is some of the stuff that gets generated, some of these vtables and stuff, file mapping, tool components, let's see, tool mode, yeah, then they have like file mapping out Win32, you have a file mapping at Unix, but respective platforms. SC, this would be the security stuff, which is, I believe this is SLA, or no, ACL, this is the ACL stuff, which is the City Core, which is it's in the client library for some reason, but don't tell anyone that. You'll be noticing all these have is a common folder, which is just an include, which has include.h. That, where does this go to? I can't remember, but it's some precompiled header that is used for certain things, which everything uses basic shit, very basic stuff, more basic than the Systems FX framework. Okay, so Probably the one thing I did not go over, which is very important when creating a new component, if you want to create a new component, that is actually, we'll probably get to this at some other time, but let me just explain one more thing. FXS Web, we are going to go in here, components. We're going to go look at, this is a Lua file, this get run, you'll put like Lua stuff, you'll put like, you put it here. You'll put your configuration files for what will be run for this component during its build. So you got extra like variable and stuff, you'll just be about with more processors and something like that. So let's just open, choose default program, Visual Studio, that my default. Alright. So this JSON file is a key part of how Premake resolves dependencies for each component. You'll see once this loads up. Alright, so in here you have this is a JSON scheme per component or whatever it says up top. I don't know why it says that, but whatever. Alright. So you have your name of your component, which is FSS Web, a version of your component, you have your dependencies, which is an array of fx, and then you have 2. I have no idea what that means. Then it also requires server implementation, server net, scripting core, resource core. Then you can also say what it provides. I don't know what the provides used for, but yeah. I think if you can make one in one component, whatever. I don't care. Let's do it. Out, I think. I don't know. So, as for this stream, I think an introduction we have done a good job with. Understanding a little bit of the framework. Really hard to do. Get to it when we start modifying a citizen server. When we start modifying FXS Web. So with all that, I don't think there's anything else to go over right now. In a future video, we will modify FXS Web, FXS Web. I'll modify it, address some of those to-dos we put in there, and some more I'll put in after this video's over, and I'll push to GitHub. And possibly another video possibly of how to create your own component and where to start, depending on what you want to do. If you want to give any suggestions of what your component wants to do, I can kind of show you where to get started, how to look into it. And also give you some info in the future on how to learn C++ and good videos to look at to learn it. So with all that, I'll see you later.